So this is a continuation of topic organic chemistry. MCQs are there for this session. We'll discuss multiple choice question, and the next session next week we will discuss the structure questions. So the first one, ketone react with hydrogen cyanide HCN in the presence of CN. Which of these ketone does not form a racemic mixture? So how we can identify it does not form a racemic mixture? Basically, there should be a chiral carbon. If there is a chiral carbon, then there will be a racemic mixture, otherwise it won't be a racemic mixture. So when we check how the reaction proceed, like if we take this first ketone, option A, so this will be C double bonded with O, and one side it is having CH3, the other side it is having CH2, CH2, CH3. So it is trigonal planar. As a result, what happens when CN will attack on the partial positive, the electrophilic addition, nucleophilic addition reaction will be there. This will form a bond, and as a result, when this will form a bond, the HCN is there. So this hydrogen will form a bond with the oxygen. So the product which is formed here, it will be C, OH will be there, then CN is there, then CH3 is there, and then CH2, CH2 and CH3. So you can clearly see this is a chiral carbon. How this is a chiral carbon? Because four different groups are attached to this. So four different groups are attached. As a result, it will be a chiral carbon. But when we check option B, in case of option B, it is a symmetrical ketone. So it is having CH2, CH3, and CH2 and CH3. What will happen when HCN is there? So nucleophilic addition reaction will occur. CN will form a bond with carbon and H will form a bond with O. So as a result, what will be the product? So it will be CH3, CH2. So COH is there, then CH2 and CH3, and then CN. So this cannot be a chiral carbon. Why this cannot be a chiral carbon? Because two identical groups are attached here, CH2, CH3 and CH2, CH3. So that's why this cannot be a chiral carbon. If it's not a chiral carbon, it won't form it won't have an optical isomer, and as a result, it does not have an optical isomer, so it will not form a racemic mixture. Because racemic mixture means the mixture which contain equal proportion of the two optical isomers. So even it does not form an optical isomer, that's why it will not have a racemic mixture. That's why B is the right answer. Is it clear, this question? Then this type of reaction is classified because the reaction started when the nitrile group attack on the partial positive carbon, and there's no group leaving or substituted. It is addition because all the substance H and CN both are added, so it is a nucleophilic substitute, a nucleophilic addition reaction. So the mechanism for this reaction, when HCN reacted with aldehyde or ketone, is a nucleophilic addition. In question 11, which of these is not observed when ethonyl chloride react with water? So if we have ethonyl chloride, CH3, C double bonded with O and Cl, reacted with water, which is H2O or HNOH. As a result, what happens? This is partial positive, OH is partial negative, and partial positive negative. So OH will take position of Cl, and the product will be CH3, C double bonded with O and OH, and plus HCl, so will be a misty fumes. So misty fumes are there, that's because of HCl. The gas given off turned the blue litmus red. That is also true because HCl is an acidic. That's why this is positive. Mixture get hotter. Yeah, that's the reactions of it. This ethanol chloride with water, they all are exothermic. White precipitate form. There is no substance here you see as a precipitate. That's why D is the wrong answer. D we don't observe because precipitate means when we mix two solution and a solid is formed, we call that as a precipitate. So here both products are even like misty fumes, hydrogen chloride gas is there, and this will be CH3 C double bonded with O, aqueous ethanoic acid will be there. Then question 12, the ultraviolet light is useful to initiate some of the reaction because what is the effect of the ultraviolet light? Ultraviolet light can break the bonds and it can produce a free radical. The UV light, as a result, the bond will break, homolytic bond breaking will occur, and it produce a free radical. So it lower the activation energy, that is a effect of the catalyst, cause the molecule, cause the bond in the molecule to stretch or the bend, that is the effect of infrared radiation, IR, cause a molecule to form an ion. That is refers to ionization like removal of electron, so it does not remove the electron. Cause a molecule to form a free radical, yeah that's true, that it can form a free radical. As a result, when free radical is formed, it can initiate different type of reaction. Is it clear? Then next question, butane 1,2-diol and 1,4-dicarboxylic acid can form a polyester, as you can see. So the question is a repeat unit of polyester. So how we can work out what will the repeat unit? Whenever diol react with dicarboxylic acid, so one side, because all of them are starting with O, so it means first I remove H, the other side OH, then H and then OH. When we start to form a polymer, so it will be O, then this is CH2 bracket 4, then OH and H being removed, so this will be O, because OCC is left, so OCC means it is O, then C double bonded with O. That's the meaning of OCC. So C double bonded with O. Then there's a benzene ring. Then there's C double bonded with O. And then it is OH being removed. So this will be, we'll put a bracket. So which one it matches with? Here, why it is wrong? Because they took diol, then dicarboxylic, and then again diol. So that is wrong because there should be another dicarboxylic acid unit. This one is totally wrong because it does not matches. When you check option C, it matches with the desired polymer. That's why C is the right answer. So whenever dicarboxylic acid react with diol, one side you remove H, then the other side you will remove OH. Is it clear? Discussion? So as a result, it will form a condensation polymer in which a small molecule of water. What type of reaction is this? So it's a condensation reaction. Hydrolysis means by the help of water, if we break down the compound, we call hydrolysis. Addition means we have only one product, we call addition. Substitution, one atom or group of atom displaces the other atom or group of atoms. But this is a condensation because the water molecule is given off. Water molecule or even HCl molecule might be given off. We call that as condensation. The equation for enthalpy of hydration means energy needed when ions in their gaseous state is surrounded by the water molecule. We call that as a hydration energy. So like first we have ions and these ions should be in a gaseous state. When these ions surrounded by the water molecule, the energy is released because bond forming is exothermic. We call that as a hydration. So when you check the option magnesium solid, so that is totally wrong. Magnesium aqueous and aqua, that is totally wrong. So what we are left with, when magnesium ion is there in a gaseous state, we add to water. As a result, that magnesium ion is surrounded by the water molecule. What we call that as a hydration energy. That's why B is the right answer. In this question, which of the following substance has this spectrum? So you have to use, they mention you may use the information on the page 6 of the data booklet. So data booklet will be given in exam. So you have to use the data booklet. Just a minute, I'll share with you the data booklet. So we have to identify which of the following substance could be using the data booklet. So propanol means OH of alcohol, that the peak will find. Aldehyde means C double bonded with O will be there, or CH is there for aldehyde. Propanol means C double bonded with O, should we'll check. And for propanoic acid, we should check C double bonded with O and then OH. So we'll check the corresponding peak. Like example, if it was an alcohol, then OH peak should be there. So for alcohol, we are getting a broad peak here. In this region, there is a broad peak. And this region, we have a sharp peak. And the region before 1500, it is known as a fingerprint region because all the elements have a unique infrared spectrum. So we don't use that. We use after 1500. So there are two peaks. So if there are two peaks, we'll check what it correspond to, because when you check, it is easy to observe. As you can see, for even without data booklet, I can just guess here that because C double bonded with O is one and OH is another. So there are two different types of functional, like two different types of bonds are there in propanoic acid as compared to any other. But we'll confirm using a data booklet, we'll confirm this. So the data booklet, page number 6. When you check for carboxylic acid, so the wave number, these are the ranges which are given for wave number for infrared correction. Correlation table is there. So when you check for OH of a carboxylic, OH of a carboxylic will have a wide, W here refers to it will have a wide range from 3300 to 2500. So you can clearly see here, it appeared to be the same from 3300 to 2500. So 3300 is here and 2500 is this value. So it appears that you are getting a range of this. And then OH of a carboxylic, this is a OH of a carboxylic, then C double bonded with O of a carboxylic. So stretching are there, aldehyde, ketones, aryl. That is, so they have a sharp peak here. So 1700 to 1800, there should be a sharp peak if this was an aldehyde or ketone. So if this around 1700, 1500, 1600 and 1700. So this is around, this is for C double bonded with O and this is for OH. Aldehyde, like if you have carbonyl group C double bonded with O, stretching is there, which is about 1700 to 1720, ketones, aryl, alkyl. And then because of the carboxylic acid, you should have 3300 to 2500. So it means one is due to OH, one is due to C double bonded with O. If it was because of aldehyde or a ketone, then you don't have this part won't be there. But because it is a carboxylic acid, so there's a peak of OH as well. So it means this is having C double bonded with O is there, and there's OH as well. So it means this is carboxylic acid, and the option D is the carboxylic acid. Is it clear? Then another question. Two ketones are there, with both have the relative molecular mass of 86. Which peak due to the fragment into a singly charged would expect to be present in a spectrum but not on the other. So how to work out this? What we'll do, we'll break from left to right and then from right to left. So example, the first one, that is CH3, C double bonded with O, CH2, CH2, CH2 and CH3 there. So what will be the peaks for this one? If we break from left side, so this will be, one is there due to CH3, so it will be 15. The other one will be CH3CO, like this part. So 15 plus 12, 27, and 27 plus 16, so that will be 43. Then 43 plus 14, so it will be 57. That is a peak of CH3CO, CH2. Then 57 plus 14, so that is 71. That is CH3, CO, CH2 and CH3 or CH2. And the last one, the molecular peak will be there for both. That is about 86. Then this is, we break from now we break from right to left, for example. And the short way, if you want to do it, you can do on the same part. Like there will be a peak at 15. There will be a peak at 43. There will be a peak at 57. And there will be a peak at 71. And there will be a peak at 86. And then there will be a peak at 15. There will be a peak at 15 plus 14. So 29 is there. Then there will be a peak at 29 plus 14. So it will be 43. And 43 plus 12, it will be 55, and plus 16. So 71, and then the last, it will be 86. So these are the peaks we'll get for first molecule. Then what about the second molecule, which is CH3, CH2, C double bonded with O, CH2 and CH3. So we'll get a peak at 15. 15 plus 14, so we'll get a peak at 29. And 29 plus 12, so 41 plus 16, so 57. 57 plus 14, so 71, and 71 plus 15, so it will be 86. And then the peak for this part, it will be 15. 15 plus 14, 29. And 29 plus 12, 41, and then plus 16, so 57 will be there. And then 57 plus 14, so 71, and 71 plus 15, so that will be 86. So the question is, which one we like, which one we are getting a unique peak? So there is 15 is there in both, so 15 cannot be, it is there in both. Then I check 43 is there. So 43 is in this one, but we don't find 43 on the other one. So 43 is there in one but not on the other, so it means 43 is a unique peak. That's why C is the right answer. But rest other, you can see like 57 is there in this one, and 57 is there the other one as well. 29 is there, here 29 is there, 29 is there. 71 is there, 86 is definitely, it will be there because it's a molecular IMP. So this is how we work out the number of the possible fragments which are present in one and not present in the other. Is it clear? Then another question, ethanol can be converted into ethanol can be converted by two-step synthesis to 2-hydroxypropanoic acid. So how we can convert this ethanol into 2-hydroxypropanoic acid? So first we have ethanol, we have to add carbon to this. Whenever we want to add a carbon, like we have ethanol, C double bonded with OH is there, and then CH3. So what we do, first we react with HCN in the presence of KCN. Because when we add HCN in the presence of KCN, nucleophilic addition reaction will occur and it will turn into 2-hydroxy propane nitrile. So it will be like this. And then what we do when we do hydrolysis of the nitrile group, as a result what it form, it will turn into carboxylic acid. So first we should react with what? Because we want to add a carbon chain to it. Whenever because 2 carbon, but in the product we need 3 carbon. So it means it how we can add a carbon to the molecule is by reacting with nitrile group. So option D, you can see we are reacting with HCN, and as a result what we do at the last, we react with dilute hydrochloric acid or aqueous hydrochloric acid, which is also known as hydrolysis. Acid hydrolysis can be acid hydrolysis, it can be base hydrolysis. By the action of acid or in the presence of acid we can do this, or in the presence of alkali it can also be done. So this nitrile group will convert into carboxylic acid. So there will be C double bonded with O and OH will be there. Like this group will be replaced by C double bonded with O and OH. So that's why D is the right answer. So when we check like sodium dichromate plus sulfuric acid under reflux, so dichromate here itself, it is reduced. It will be an oxidizing agent. It is used to oxidize the substance. It will oxidize, like directly aldehyde will convert into carboxylic acid if we use this one. Chlorine in the presence of UV, that is a substitution reaction is there, so we don't want. Lithium tetrahydrodualuminate in dry ether is a reducing agent, so it will reduce this aldehyde into alcohol. But we don't want it reduced first, because in the given we have ethanol, but as a product we have propanoic acid, so we need more carbon, or we should add a carbon. So whenever we want to add a carbon to a molecule, we always react with HCN in the presence of KCN. Is it clear, this question? So these are the reaction conditions which you have to learn to carry out certain changes. Question A to D concerned with the organic compounds. So A, B, C, D are the compounds here. Select from A to D a compound that forms iodoform. Iodoform means, like if methyl group is there next to functional group or carbonyl group, it will give a positive iodoform result. So we have to check all the 4 compounds, like which one carbonyl group is there, methyl group is there next to carbonyl. And even if it's an alcohol, alcohol will be oxidized. Like if we use, so if this alcohol, first if this alcohol is oxidized, oxidation means addition of oxygen or removal of hydrogen. So if it is oxidized, but this carbonyl group, when it will form a carbonyl group, next to that is not a methyl group, because it will give a positive result when next to carbonyl group there is a methyl group. So even if we add first, alcohol will oxidize, but again when a carboxylic group is carbonyl group is formed, that will not have any methyl group, so it won't give a positive result with or positive iodoform result. When we check the second one, so C double bonded with O is there, and next to that is a methyl group. So it means this will give a positive result. It will give a yellow or orange precipitate. Yellow precipitate is there. Here when we check C double bonded with O, next to that is not a methyl group, because this is a carbon chain, and but that is not directly, methyl group is not attached. When we check this one, C double bonded with O, next to that is not a methyl group, so it won't give a positive result. So the correct answer, that a compound which will give, which forms iodoform with iodine, that is in the presence of alkali, so compound B is the right answer. Is a chiral. To be a chiral, it should have all the different groups attached to it. When all the different groups are attached, we call that as a chiral carbon. So when we check, we have to check each carbon. So this cannot be a chiral carbon, the A. When we check this one, this cannot be a chiral because two methyl groups are there, so this cannot be. When we check this one, so this look a chiral carbon. How this looks a chiral carbon? You can see one side it's H, one side is OH, one side is CH2, CH3, and the other side is this whole structure. So it means four different groups are attached. So it means this will be a chiral carbon, or it will give up, like it will have effect on the plane polarized light. That's why for question part B, which is a chiral, so A is a chiral. Toluene reagent, it is basically a test for aldehyde, toluene or phthalate or Benedict solution. These are the tests for aldehyde. So which one of them is aldehyde? This will give a positive result. So when we check this, look, even though it is alcohol, but when oxidation occurs, this alcohol will turn into what? This alcohol will turn into, because it's a secondary alcohol turn into ketone. So it will form a ketone. And that ketone won't give a positive result, so it cannot be an answer. When we check this one, this is actually a ketone. Ketone does not give a positive result. This one C double bonded with ONH, so it means it is an aldehyde. An aldehyde give a positive. This is not. This is an ester. Ester also does not give a positive result. So the correct answer is C. That compound C will give or react with toluene and can be oxidized to form a ketone. So which alcohol can, secondary alcohol can be oxidized to form ketone. That's why A will be the right answer for the last one. So this was C and this one is A. Is it clear? Then ethanoic acid can be converted into ethanol chloride by, so what we do basically when we react them with PCl5, so if you have CH3, PCl5 is also a test for the presence of OH group for alcohol and for carboxylic acid. So if it is PCl5, phosphorus pentachloride, as a result, one of the chlorine will displace this OH, so it will form CH3C double bonded with ONCl plus POCl3 plus HCl. As a result, it will produce a misty fume. So for question 13, A is the right answer. Compound Q gives an orange precipitate with 2,4-dinitrophenyl hydrogen. So that is a test. This is a positive test for both aldehyde and ketone. Both give a positive result with this. Compound Q resists oxidation. So compound Q cannot be oxidized. It give a positive, so it means it is an aldehyde or ketone. It resists oxidation. So it means it cannot be oxidized. So it gives an idea it is ketone. Because aldehyde can be oxidized, ketone cannot be oxidized. So first observation gives an idea it might be aldehyde or ketone. The second observation in which it cannot be oxidized confirm that it is a ketone. And on reduction it give a product made up of a pair of optical isomer. So means it contain a chiral carbon. So when we check the options, so only this is alcohol, this is aldehyde. We cannot have B and C. So we are left with A and D. When we check, because when it is reduced, ketone will reduce into secondary alcohol. So it will be CH3, CH2, the reduction product I'm drawing. CH3, CH2, CH2, C, OH will be there, H will be there, and then CH3. So you can clearly see it will have a chiral carbon when reduction product. So because the carbon is forming a bond with four different types of group, one side it is CH3, another side is CH2, CH2, CH3, OH and H. So this will be a chiral carbon. So A will be the right answer. Why not D? Because as a result of this reduction, D won't form a chiral carbon as it will have identical groups on both sides. So C2, CH3, CH2. So identical. So it won't be a chiral carbon. It can be reduced to alcohol, but the product will not have a chiral carbon. So it won't have optical isomer. That's why A is a valid answer. Is it clear? Question 14. Then select the correct state of stationary phase and mobile phase in HPLC, high performance liquid chromatography. So high performance liquid chromatography or HPLC, the stationary phase are the fine solid and the mobile phase is a liquid. So that's why C is the right answer. But if it was gas liquid chromatography or a gas chromatography in which gas is a mobile phase and a liquid and a solid can be refers to a stationary phase. Yeah, this is column chromatography as well. HPLC, high performance liquid chromatography, is also known as column chromatography. We allow the liquid to flow out and work out retention time and identifying the amount of sample. This question is about low resolution proton magnetic resonance spectroscopy, nuclear magnetic resonance spectroscopy, which involve hydrogen nuclei in the presence of powerful magnetic field with. So what we do, which kind of radiation we use a radio wave. So the hydrogen nucleus or proton absorbs this and it changes the spin, which changes the magnetic field. Which of the following has a two peaks in low resolution NMR? So when we check dichloromethane is only one hydrogen environment, because dichloromethane is like C, H, Cl and Cl. So this is one hydrogen environment. So it won't be. When we check this one, so this is also one, identical environments are there. So this is A. So one hydrogen. In methanol, when we check methanol, so it is C double bonded with O, H is there and then H is there. So this is also identical. So it means it will be one. But when we check methanol, this is one. This whole is one hydrogen environment. and this is the other hydrogen environment. So two different hydrogen environments are there. That's why D is the right answer for this. Is it clear? NMR spectrum depends on number of hydrogen environments. How many different hydrogen environments are there in a molecule of 2,3-dimethyl pentane? The skeletal formula is shown. So if a skeletal is shown, you can draw, because it's easy to identify from structural formula or the displayed formula, that this will have hydrogen, or CH I can say. Then next is, because 4 bonds are there, so there will be no hydrogen. The next one, 3 bonds are there, so there will be 1 hydrogen, sorry. This will be CH3, and then this carbon is CH2, and then CH3. So now we have to check how many hydrogen environments are there, total number of hydrogen environments. So when we check, these two are 1 because they are attached with the same. So this is A, or I can say A. This is B because CH is there, nothing identical like this. This one is C, this one is D, this one is E, and this one is F. Because why even this CH3 is different from this? Because this CH3, next to that is CH, like other groups are there, other chain length is different. But for this CH3, CH is there, and next to that is CH2, CH3, and CH2, CH3. So we have to check the not only the first, like example, CH3 is there, we don't check what is next to that. We check throughout the chain, it should be identical. That's why even though these are methyl groups, 4 different methyl groups are there, 2 of them are identical in terms of environment, and rest 2 are different. So this will be F. So 1, 2, 3, 4, 5, and 6. So that's why B is the right answer. Is it clear, this question? How we draw out from the skeletal formula? Skeletal formula shows carbon. Look, this is 1 carbon. Next to that, there is another carbon. Top of that, there is another carbon. And next to this, attach a carbon. Next to that, there's another carbon. Next to this, there's another carbon. And next to that, there is another carbon. So this is, we draw first carbon, and then how many hydrogen? Because 1 bond is there, so this will have 3 hydrogen. 1 bond, 3 hydrogen. 3 bonds, so 1 hydrogen. 1 bond, 3 hydrogen. 3 bonds, 1 hydrogen. 2 bonds, 2 hydrogen. 1 bond, and 3 hydrogen. This is how we draw the structure. And from structure, we can work out the number of hydrogen environments. Like these two are identical, A, then this is CH. There's no other CH, so that's like this. There's another, but this CH is attached to 2CH3, but this is attached to 1, so it means they are totally different environments. So this CH3 is different, this CH2 is different, and then this CH3 is different. So 1, 2, 3, 4, 5, and 6 hydrogen environments are there. Is it clear now? Then this is about the hydration energy. Hydration energy is energy released when the ions in the gaseous state surrounded by water molecule in aqueous. So this is less exothermic than magnesium. What is the reason for that? Because the hydration energy, as we go down the group, hydration energy decreases. Like magnesium will have a higher lattice in hydration energy compared to calcium. Calcium will have higher than compared to strontium, because strontium is larger, ion is big, larger in size. So strong bond is there for magnesium and oxygen as compared to calcium and oxygen, or calcium and water molecule. And strontium, because larger size, so less attraction, so less energy will be released. So what is the reason why? And hydration energy is always exothermic, because the bond forming is exothermic. So as we go down the group, the ionic radii decreases. That sorry, as we go down the group, the ionic radii increases, so hydration energy decrease. So why magnesium, ionic radii of magnesium is smaller, that's why, compared to strontium, so that's why magnesium will have a higher exothermic or higher hydration energy compared to that of strontium. So D is the right answer. In question 10, which of the following solution when mixed would make a buffer with a greater pH 7? So pH buffer solution when weak acid mixed with its salt or weak alkali. So because we want to make a buffer solution pH more than 7, so it should be a weak alkali and its salt. So which one is weak alkali and its salt? So ammonia and its salt. So D is the right answer. But why not C? Or because this is totally wrong. Sodium hydroxide is a strong base. Ammonia is there, but not, this salt is not of ammonia. That's why it is not forming a buffer solution. And this is sodium ethanoic acid plus sodium ethanoate. That will form a buffer solution, but that buffer solution will have a pH less than 7. But in the question, we need pH more than 7. In acid solution, methyl orange is red. When alkali is added, the solution turned yellow, because the indicator, basically indicators, we have HIN. They, like, this is a representation of indicator molecule which are also weak acid that dissociated to H plus and IN minus. So when we add an alkali, so when alkali is added, alkali means OH is there. So this OH will attract the hydrogen ion. As a result, molecule will dissociate or break down into more hydrogen ion. So what will happen to the indicator? The indicator will lose its proton to form an anion. That's why D is the right answer. This was related to acid topic, but we are doing now organic only. That's why I quickly go through. Which of the method could be used to make carboxylic acid in a single step? So if we want to do, or if we want to prepare carboxylic acid in one step, if we do hydrolysis of the ester in the presence of sodium hydroxide, so as a result, what happened? Because when ester will hydrolyze, it will produce carboxylic acid and alcohol. But that carboxylic acid will react with sodium hydroxide, so it won't be correct. When ester is hydrolyzed in the presence of acidic condition, so acid cannot react with that other acid. That's why B is the right answer. Reaction of acidified potassium manganate with alkene, that will produce diol, but we don't want to produce diol. And acyl chloride with ammonia, so it will produce amide, that will be the product, but we want to produce a carboxylic acid. So A and B can produce carboxylic acid, but in case of B, in case of A, the product which is carboxylic acid will react with sodium hydroxide. So we should carry out the hydrolysis of the ester in acidic condition. In 13, which of the following pair of a compound would react to form a polyester? To form a polyester, because it should be either diol, like alcohol mixed with alcohol, or carboxylic acid mixed with alcohol, or amine mixed with carboxylic acid, or it should be ethonyl chloride mixed with alcohol. So which of the following? And to form a polyester, they should have both ends. Like ethanol can react with benzoic acid, but it should be like both ends should have that functional group. Here, ethanol means it should have only one OH group, and benzoic acid means a benzene ring is there. This is a benzene ring. We'll discuss in unit 5. So this is a benzene ring. It's have benzoic acid means only one OH C double bonded with O. So it cannot form because polyester or a polymer should have a repeat unit. There will be a reaction, but there won't be a repeat unit. Here diol react with benzoic acid. Again, there is no repeat unit. Ethanol, one side is ethanol, 1,4-dicarboxylic acid is correct, but ethanol only one side OH group is there, so it won't react. Diol, diethane, ethane 1,2-diol means you have two carbon atoms in between and both side you have OH group. And 1,4-dicarboxylic acid, what does it mean? Benzene 1,4-dicarboxylic acid, it means benzene ring is there and both side you have carboxylic acid. 1 and 4 are the position of the on the ring. So 1, 2, 3 and 4. So both side you have carboxylic and both side you have alcohol. So this will leads to a formation of a polyester. Is it clear? The polymer can form when you should have functional group present at both ends, not at one. Then in question 14, which of the following compound has both optical and EZ isomer? To be an optical, there should be a chiral carbon. Chiral means there should be different groups attached to carbon. And to be an optical, to be geometrical, there should be carbon-carbon double bond and two different groups should be attached like so we can compare their mass, not CH2. So D cannot be an answer because there is CH2 here. This also cannot be an answer. B cannot be an answer because it is like CH3 is attached with both one. So you're left with A and you're left with C. So A and C both can have geometrical, but when we check optical, there should be different groups attached. This cannot be a chiral carbon. C double bonded. C can never be a chiral carbon because two groups are like double bond is there between the two. So this cannot be chiral carbon. So there is no chiral carbon. But when we check here, this carbon is a chiral carbon which is having H is attached, Br is attached, CH3 is attached. So that's why C is the right answer. Because when we draw, it will be HBr. Always remember the carbon-carbon double bond can never be a chiral carbon. This is having HBr and then CH3. So this is a chiral carbon which is having a different groups attached to it. So C is the right answer. Which of the following mass to charge would not be expected in the mass spectrum of ethonyl chloride? So ethonyl chloride, you have CH3, C double bonded with O and CH3 or Cl. This is straightforward question because the 35.5 either chlorine, look, either chlorine is 35 or either chlorine is 37. Average mass of the two isotope is 35.5, but you don't have a mass of a chlorine atom which is have 35.5. It's the average mass of the two isotopes. So it can be a other number, but it can never be 35.5. Like even if I get chlorine, I might get 35, I might get 37, but I don't get 35.5 because that is the average mass of the two. But if we have one chlorine, either it will be 35 or either it will be 37. So that's why A is the right answer, which we don't expect because that is not the mass of chlorine atom, that is the average mass of the two isotopes. Is it clear, this one? So this was the exercise, multiple choice questions related to organic chemistry. The next session, we will do the structure questions and we'll conclude this unit for next session. Any question or a doubt related to the class? Okay, so I'll end the session and share this with you.